The Sun is the star at the center of our solar system, providing the energy necessary for life on Earth. It is a nearly perfect sphere of hot plasma with internal convective motion that generates a magnetic field via a dynamo process. G-type main sequence star, also known as G2V, age approximately 4.6 billion years. Mass 1.989 times 10 to the 30th kilograms, or about 330,000 times Earth's mass. Diameter around 1.39 million kilometers, which is 109 times Earth's diameter. Surface temperature roughly 5,500 degrees Celsius or 9,932 degrees Fahrenheit. Core temperature a staggering 15 million degrees Celsius or 27 million degrees Fahrenheit. Composition 74% hydrogen, 24% helium, and about 2% heavier elements like oxygen, carbon, neon, and iron. The core is where nuclear fusion occurs, converting hydrogen into helium and releasing enormous energy in the form of gamma rays. In the radiative zone, energy moves outward as electromagnetic radiation, with photons taking thousands of years to pass through. The convective zone sees hot plasma rise, cool, and sink, transferring heat. The photosphere is the visible surface of the Sun, emitting sunlight and showing sunspots due to magnetic activity. The chromosphere is a reddish layer visible during solar eclipses. The corona is the Sun's outer atmosphere, extremely hot at 1 to 3 million degrees Celsius, and is the source of the solar wind. Sunspots are dark, cooler regions caused by magnetic disturbances and follow an 11-year solar cycle known as solar maximum and minimum. Solar flares are sudden bursts of energy due to magnetic reconnection and can disrupt satellites and power grids on Earth. Coronal mass ejections, or CMEs, are massive expulsions of plasma and magnetic field that cause geomagnetic storms and auroras, such as the northern and southern lights. The solar wind is a stream of charged particles flowing from the Sun, extending the Sun's magnetic field into the solar system. The Sun fuses about 600 million tons of hydrogen into helium every second. This process releases energy via Einstein's famous equation, E equals mc squared. Interestingly, it takes about 100,000 years for this energy to travel from the Sun's core to its surface. The Sun formed around 4.6 billion years ago from a molecular cloud. Currently, it is in the main sequence phase, which lasts for a total of about 10 billion years. In approximately 5 billion years, the Sun will enter the red giant phase, expanding and possibly engulfing Mercury, Venus, and even Earth. Eventually, it will shed its outer layers, forming a planetary nebula, and leave behind a dense core known as a white dwarf. The Sun supports life by providing light and heat necessary for photosynthesis. It drives our weather systems, with solar energy powering Earth's climate. Additionally, space weather impacts from the Sun affect our satellites, communications, and power grids. Ground-based telescopes allow us to observe sunspots, flares, and solar storms. Space missions like the Solar and Heliospheric Observatory, or SOHO, have given us invaluable data. The Parker Solar Probe has made the closest ever approach to the Sun, and the Solar Orbiter studies the Sun's poles and magnetic fields. Did you know the Sun contains 99.8% of the solar system's mass? Light from the Sun takes 8 minutes and 20 seconds to reach Earth. Interestingly, the Sun is actually white, but it appears yellow due to Earth's atmosphere. The Sun is a dynamic and essential star that sustains life on Earth. Understanding its behavior helps us predict space weather and prepare for future solar events. As technology advances, we continue to uncover more mysteries about our closest star. Would you like more details on any specific aspect of the Sun?